I want to show you another type of factoring we might use. This is called factor by grouping. I use this when I have 4 terms. Okay, I call it factor by grouping because I'm going to group the first 2 terms together and I'm going to group the second 2 terms together. In the first 2 terms I'm looking for a common factor. I can divide both of these by x cubed. Okay, so 6 and 5 do not have a common factor, but I can take 3 x's out of both of these. It'll always be the smallest exponent. So what do I multiply this by to get that term? Well, 6x to the 4th power divided by x cubed is 6x. If I multiply these two back out, I get 6x to the 4th power. Plus, it's positive, and then I'm going to divide out, I get 5. So 5x cubed divided by x cubed is 5. If I multiply these back out, I get this term right here. Okay, now with my second pair of terms, I'm going to do the same thing. This time I have a choice if I'm going to take a positive or negative out. When I'm making that decision, I'm looking at what's inside this parentheses, because in the end I want the parentheses here should look the same. So I see that I can divide both of these terms by 4. If I divide this by 4, I'm going to get negative 6. I don't want negative 6, I want positive 6. So I'm going to divide both of these by negative 4. So that's how I decide if I'm going to divide by a negative or a positive. Okay, I cannot take a variable because this is just a constant term. There's no x here. So what do I get when I divide both of these terms by negative 4? I get 6x negative divided by negative plus 5. Again, multiply this back out. Negative 4 times 6x is negative 24x, and negative 4 times positive 5 is negative 20. Okay, now what I've done is essentially I've created 2 bigger terms here, because this is multiplication, a monomial by a binomial, and this is multiplication, a monomial times a binomial. So I now have 2 terms. And I'm going to use the distributive property again. I'm going to factor out, in this case, the binomial. So they both have this 6x plus 5 in common. So I'm going to factor that out. What does it leave me with? Well, 6x plus 5 times x cubed gives me the first term. And then 6x plus 5, the sum of 6x and 5 times negative 4 gives me the second term. So it's essentially what's the coefficient of the 2 binomials. That's the 2 terms that go inside here. Okay, now just like always with factoring, I can check this by storing an irrational number. Any number will work, but irrational numbers are safe. So I like to use pi. That's my favorite one when I only have one variable. So I only have one variable, it's x. So I'm going to store pi into my calculator for x, into my variable here. So second pi, I'm going to use my store key right here, stow, put that into x. Okay, if I have factored correctly, my original expression, 6x to the 3rd power, get out of the exponent, oh wait, no sorry, go back to the beginning, the 4th power, plus 5x cubed minus 24x minus 20. Okay, so always the original problem. Just double check here. Yep, looks good. Okay, enter. And now, if I'm correct, when I put in the simplified answer I got, these 2 should be equivalent. 6x plus 5x to the 3rd power minus 4. Okay, they're equivalent. So I know that I factored correctly. This does not mean that I factored completely. So I always just double check, look at my original expression, look at my final answer. Can I factor anything else out here? Is it a special case? I've got a binomial, no common factor, not a special case. Okay, I can't do anything further, so I'm feeling pretty good about my answer. The 2 are equivalent.